Hello, and welcome to our program, Astronomy for Everyone. The topic of this month's program is the upcoming total solar eclipse that will be crossing our country. And with me here in the studio to talk about it is our own Tim Campbell. Tim, welcome back to the show.
Thank you, Don. Thanks for having me back.
Well, now, a total solar eclipse. I think this is the first one since 1979 that has crossed our country?
It's been a while. Actually, I think it goes back for one that crosses the entire country coast to coast. It goes back quite a few more years than that. I think we're at 99 years now.
Wow.
Yeah.
Wow. That's quite a long time. So this is going to be quite an event. So I think we should really start out and not assume that a lot of our viewers understand the mechanics or dynamics of what an eclipse is. I mean, just what causes an eclipse?
Sure. Okay, so we've got a clip for you that you can watch. When the moon passes between the Earth and the sun, most of the time we don't get an eclipse, but sometimes if the moon is in just the right spot, it will black out our ability to see the sun, and that's when we have an eclipse. If it happens to be in a place where we can get right in the very center of the shadow, we may see totality, a total solar eclipse, if the moon is a little bit closer to the Earth. If it's a little farther away, we get something called an annular eclipse, which means it's a little tiny ring of light encircles the sun, but this one will actually be total. And we don't get them often, but just occasionally we do.
Now, the reason why we don't have them every month would be that the tilt of the orbit of the moon around the Earth with regards to the sun?
Yeah, so we have another video clip that you can take a look at. And in this one, we show that the moon's actually quite tiny. It's only about a quarter of the size of the Earth, and it's about 30 Earth diameters away. So the shadow that it places on the surface of the Earth is actually quite tiny. And the Earth's orbit goes around the sun in a plane that we call the ecliptic plane, but the moon is not in that same plane of orbit. It's off by about 5 degrees, as you mentioned, and that means that most of the time when the moon goes around, it'll be a little bit too high or a little bit too low. I've got a little model here that we can sort of demonstrate that with, and in this model I show the moon. Now again, only about 5 degrees, and you can see that I really don't have to move this moon, this stick very much at all. And you know, the moon over the Earth really completely misses it. So it doesn't take much for a near miss. It's farther away than we think, and it's tinier than we imagine. And so it's not tough for the shadow to completely miss.
So it's only at those 2 points where those 2 orbits cross, the Earth-Moon and then Earth-Sun, where those orbits cross, then that's when we would have the opportunity of either a solar or a lunar.
That's correct, and not even for the whole planet, right? So you got to be in just the right spot. So this time it happens to be, you have to be in the U.S.
Exactly. We saw in that one video clip, it almost looked like a pinpoint of shadow coming across the United States,
right,
versus a lunar eclipse where everybody on that side of the Earth can see it. So.
Yes, and so everybody in the United States will see something if you're in the continental United States. But the path of totality is only about 60 miles wide, about 30 miles either side of the center line, and you're close enough to see totality. If you're anywhere else, you won't see totality.
Because that was going to be my next question. Can they be seen everywhere? But it sounds like you've pretty much covered that topic. And really, where would be the best place to be to see this eclipse?
So we've got another clip for you, and if you take a look at this, this shows the shadow coming across the country, and you can see it enters through the state of Oregon. It's going to exit through South Carolina. Right now it's going over Casper. Those sort of rings that you see around are just showing different areas of totality. The closest one, if you're within that closest area, it's 90% totality. Detroit will get about 80% totality in Detroit. It's 75% totality and a little less. Every place in the country, in the continental 48 states, will get at least 50%. Most places will get significantly more than that. I mentioned Detroit will get 80%. But what you see in totality versus what you see in non-totality is completely different. The experience, there are a lot of things that can only be experienced if you see totality.
And being within that path that we saw
correct,
etched out on the map. Now here up on the screen, this looks like the moment of totality.
Correct. So this is actually done with simulation software. So this isn't a real eclipse photo. You'll see the solar corona encircling the sun. That's an outer area of the sun's atmosphere that normally when the sky is bright, it's washed out and we don't notice it at all. But during an eclipse, the moon just nicely fits over the sun, blocks that, and we can see the corona itself. Just off a little bit to the left of the sun, you see these funny blue lines. Again, this is simulation software. That star that you see, that's Regulus.
In Leo.
It's in Leo, correct. And there's another image that zooms out. You can see all of Leo. That star is only going to be about 1 degree off of the sort of eastern edge of the sun, if you will. And that's a pretty bright star, about 1.3 is the magnitude.
Yep, very bright.
Sure, yeah. And so you'll see that star. If you're in totality, that's bright enough. So the brighter stars of the sky you will see. The fainter ones you may not see. Now, some people use an eye patch to allow one star to remain dark adapted.
Okay.
And by doing that, that eye is used to seeing in the dark because they've covered it up. And so when they take that eye patch off during totality, they see a lot more detail.
Their pupils open wider so they
Exactly.
can pick up
Yep.
more. Okay, so that's a interesting little trick there. So again, when we watch that animation, that sort of reddish or rust-colored line, that's where you need to be in totality.
That skinny little spot, if you can get there, that's the place to be.
And judging from looking at the video there, sounds like Casper, Wyoming is dead center on that.
It's kind of an ideal place. There are quite a few really good places. We tend to have more cloudy weather east of the Mississippi. Gulf moisture gets pulled up. Now it is in August, which is one of the better months for an eclipse. It tends to be a drier month, not so stormy. But east of the Mississippi is a higher probability of cloudiness than west of the Mississippi, especially if you're east of the mountains. You sort of get into those plains areas. That tends to be pretty good chance that you're going to have sunny weather.
Out west, say Nebraska or Wyoming,
Yep.
might be a better spot than down, say, in Tennessee or South Carolina.
Yes, I would say so. It's hard to get places. Hotels are typically gone, campgrounds are typically gone, so the new technique that people are doing is trying to find a place that's not in the path of totality but near, and then maybe they'll try and drive onto the path of totality early in the morning before the eclipse happens.
Now, we've talked about it coming up. Have we mentioned a date for this yet?
Yeah, so the date is August the 21st. Everywhere in the United States, it'll all happen on the 21st. I have the times displayed. If you're not going to leave Detroit, you won't see totality. You'll see about 80%. So you'll still see a bit of the sun slicing through. It'll start for us here just after 1 o'clock, and then at about 3:45-ish, it'll all be over. So you get about, about 2 hours and 45 minutes for the entire event from end to end.
All right, and the maximum eclipse would be approximately 2:30 when
Yep.
we would be at that 80% maximum for here in Southeast
Correct, yep.
Michigan. Okay, very good. Also, by the way, August 21st is a Monday, in case anybody's wondering.
Yep.
Add an extra long day for your weekend to be able to check out the eclipse. So, again, if folks are thinking of trying to find a spot under the path of totality, it sounds like they're pretty much out of luck at this point in April of 2017.
I'm told there are a few places available if you are going to agree to opportunistic pricing.
Ah, yes, that's a good way of putting it, I think. Yep, okay, we're running the video again. Looks like Eclipse, Kansas City and St. Louis, but now we're getting east of the Mississippi. And I think the point of maximum totality, isn't that in Kentucky?
I think that's right. I don't have it marked on that. But yeah, so there's a place where you get just a fraction more time. Everybody gets a little over 2.5 minutes for most places, but some places will just get a fraction of a few more seconds.
Okay, but it wouldn't vary that much. But
No, it's not that much. Now, what does make it vary is if you are not on the center line. So as you start to go toward the edge of that 60-mile band of totality, as you get to the edge, then it starts to get reduced time.
Okay, all right. So we've talked about what an eclipse is. We've really gone over the dynamics of it for folks who might not be clear just about how that works, and the fact that you need to be in a very specific place along a certain path to be able to view this eclipse. Again, much different than a lunar eclipse, which is viewable from just about everywhere.
Sure, and safe, right?
And much safer,
Yes.
much safer. And we're going to be talking about viewing safety in the second part of the presentation here. So it seems like this would be a good spot to take our break. If you have any questions, you can send us an email. The address, as always, is down at the bottom of your screen. So we do like to hear from you. And coming up next, we have Term of the Month with Stephen. So stay tuned for that. And once Stephen is done, we'll be right back with more of our upcoming total solar eclipse.
The term of the month for April 2017 is syzygy. This comes from the ancient Greek word meaning yoked together. And the definition is 3 astronomical objects that are in a line. For example, during a lunar eclipse, the sun, the earth, and the moon. Or during a solar eclipse like this summer, the sun, the moon, and the earth. And if that's not good enough for you, it makes a great hangman word. Syzygy, term of the month.
Thanks, Stephen. Welcome back, folks. We're continuing our discussion about the upcoming total solar eclipse that'll be happening this coming August, I should say. And again, with me is Tim Campbell from the Ford Club. Now, Tim, what can we expect to see?
Oh, so what you can expect to see all depends on where you are. If you are not in the path of totality, what you'll see is the moon just sort of taking a bite out of the edge of the disk of the sun, and it'll increase. But before the eclipse ever becomes full, it'll start backing away again. It'll basically swing around to the far side. You can see we've got a video showing it now. If you look at the right side of the screen this time, you'll see the moon is basically taking a bigger and bigger bite. This is played at a very accelerated rate. And then it'll sort of swing around below the sun, so you won't actually see that totality moment there. So the moon will be just slightly off to one side. Because you do have to worry about safety when you look at the sun. You will at all times, if you're not in totality, at all times you'll need to worry about eye safety, and we'll talk about that shortly. If you are in totality, however, quite a few interesting things happen, and some of them start happening even before totality arrives. So, maybe 30, 40 seconds before totality arrives, if you look around at anything that's giving good shadows on the ground, a piece of white poster board, or a white piece of fabric, or a white car, for example, look at the white, and as the totality is starting to approach, you'll see these things we call shadow bands, and the sun will start giving these ripply shadows, textures that will start to appear, kind of like if you're looking at the bottom of a swimming pool and you're making waves on the surface just gently, you'll see the shadow of those waves on the floor of the swimming pool. You'll see that happening as totality gets close. Effect? Yes, and it just sits there and ripples. It looks really cool. It's not something we normally see, caused by the atmosphere, and that's coming up just before totality begins. And then around the 9 seconds to maybe 7 seconds before totality begins, another effect happens, which is what we call the diamond ring effect. So here's an image of it. The sun almost seems to be, the moon, seems to be encircled in almost some light with a really bright glow right off to one edge, and that's the spot where the moon hasn't quite completed covering up the sun. And they call that the diamond ring effect, and if you imagined a ring with a stone in it, with a hole, and that's why they call that the diamond ring effect. Then a few seconds later, and now we're getting down to maybe 1.5 seconds before totality begins, the moon isn't a completely flat object, right? It actually does have terrain, it has mountains and things like that. And now we're really getting to the point where the sun can barely peek past, and so through those peaks, that glow of light starts to get broken up by the terrain on the moon, and it breaks into what appears to be a series of white dots, and they call that the Bailey's beads effect.
The sun shining through the mountains or through the valleys.
The last vestiges of sunlight before totality actually begins, and then the big moment. By the way, if you can stand on a high hill before all of this happens, you may see racing across you, coming at around, I want to say it's 1,500 miles an hour, my speed might not be correct, racing toward you come these shadows of the moon. You'll see it again as totality leaves, racing away from you. You might not notice it if you're at ground level, but if you happen to be on a hill.
Seeing off into a distance, just to see that coming forward.
In the same way that you can see the shadow of clouds as they approach, if you can see the Earth, you'll see the shadow of the moon. So then you get the big moment of the solar corona. So that when totality actually finally occurs, you see this solar corona. It's an outer area of the sun's atmosphere, and it has this massive amount of energy. What's strange is the surface of the sun is about 6,000 degrees Celsius, and yet the solar corona is many millions of degrees, many, many, many times hotter than the surface itself. And it's an area that we normally can't see because of the blue sky, but you can see it during a total solar eclipse. You get that. Now, this is an image taken by someone that required a lot of camera exposures to put this together. You probably won't see an image that looks like this with your eye. What you'll see is the part that's closest to the sun. That will be visible to your eye.
But this spread out that we see here, this is time-lapse photography.
This is many exposures. You need about 12 different exposures to be able to capture all that detail. There is a trick of using the eye patch. It takes about 40 minutes to completely dark adapt your eye to the darkness, but in about 20 minutes you're most of the way there. So they suggest about 30 minutes before totality, put an eye patch on.
Okay.
You can see with one eye, the other eye is now getting dark adapted. So when totality actually occurs, you take that eye patch off, and that eye will now be much more sensitive. You'll see more corona with that eye. You'll see a lot more stars in the sky with that eye.
The pupil will have opened up a lot.
Yes, exactly, because you're sort of using that cheat. Totality is only about 2 minutes long, and it takes about 20 minutes to dark adapt.
Yeah, so you're not going to get it just waiting for the totality.
Right, and then after that, you see all of those effects again, except in reverse. So you'll start to see the Baily's beads appear, the diamond ring effect for a second time, going out the other way, and then you'll finally see the moon ultimately receding away. And of course, as totality ends, you may see the shadow racing away.
And so all of this is in the time of about 2 minutes and some seconds.
Yes. I think the greatest duration, depending on where you are, I want to say it's around 2 minutes and 40 seconds, give or take.
Totality. Okay.
Yeah, for totality. Not everybody will get that. Some places, even if you're on the center line, the western states and the eastern states, that area near Kentucky that you mentioned, they get that. Shave a couple of seconds off for those places. So you only get a couple of minutes. Those who have experienced it say it just, even though 2 minutes, if you're really counting it out, would seem like a lot of time, it seems like a blink of an eye.
Just caught up in the moment, it's sort of an ethereal effect. I have never seen one, so I've had other people describe it as you have described it.
For most people, this will be their first time.
Now, we talked about looking at the sun during totality, if you're in that path of totality. How do we view a solar eclipse safely?
Okay, so, and this is an important topic. I never talk about the sun without bringing up the safety topic. You're not supposed to stare directly at the sun. I talk to middle school students from time to time, and I ask them, how many of you have been told not to look at the sun directly? And of course, all of them raise their hands, and then I ask them, how many of you looked at the sun directly in spite of being told that you're not supposed to do this? And of course, almost all of them raise their hands again. So why aren't they blind? Right? They should be blind. It turns out looking at the sun for a second or two is probably not going to harm your eyes. It's looking at the sun for many seconds that's harmful. I can't give you an amount of time because eye doctors will say, depending on your eye conditions, that time can be very different for many people. So, so we do still want to say never look at the sun directly with the unaided eye. At least not with your last remaining working eyeball. Okay. Make sure that one is still good. So you want to make sure you're using proper eye protection. Now there's two things you can do. You can look at it directly if you have proper eye protection that's designed specifically for looking at the sun. And I'm very careful about that. People will, I'll use 3 pairs of sunglasses stacked on top of each other. Not even close. No. Right? It needs to be something that's designed for safe viewing. So this is a very inexpensive piece of cardboard. I happen to order this one from Thousand Oaks Optical. It looks like a sort of black piece of plastic. And in fact, if I did this in the planetarium, I took a flashlight to try and shine it through, and you actually could see the light shining through the cardboard, but could not see it through the part that's actually supposed to be transparent. And it's a special type of plastic. It's a special type of plastic. This is solar film. It blocks the sun's energy both in the visual spectrum as well as in the infrared, which our eyes can't see, but the sun is still perfectly capable of damaging your eyes that way. There are no pain receptors in your eye, so as you're doing this, you don't know that you're damaging your eye. Also, the effect is not immediate. I'm told it can take 24 to 48 hours before the damage really starts to set in, and so you think you got away with it, and then you wake up a day or two later and realize something is very wrong. So make sure you use something like one of these. I brought these along. These are similar. These come in various sizes, and you can see that, you know, this one is a little bit larger than this one is a little bit larger than this one. They come in all kinds of diameters. And this has solar film in it. They also have solar glass versions as well. And the idea behind one of these filters is that you cap them over the front of a telescope. If you have a telescope, you can get small ones for binoculars. You can even get them sized to cap over photographic camera lenses.
Interesting.
If you wanted to do that. You can also get this in sort of a pair of cardboard fold-up sunglasses that you put on. It does filter out 99.999%, so only one photon out of every 100,000 makes it through. If you don't have this, you need to use an indirect viewing method. A common technique is 2 pieces of cardboard, a sheet of paper on one side, piece of aluminum foil, cut a small hole in the other one, put a piece of aluminum foil over it, and carefully put a pinhole in it. And you'll get the projection of that crescent sun on the sheet of paper if you do that. Kind of like a pinhole camera.
Yeah, a projection system, if you will. Now, in our few remaining moments, for somebody who's a first-time viewer, should they try and image this, or should they just sit back and enjoy the moment?
So I will be imaging it, which is really to say I will not be imaging it. A computer will be doing all of the work controlling my camera. I plan to have a good time. We warn people that if you get your head buried in the camera, there are so many things you have to do with the exposures. You're probably not going to get it right your first time, and then you're probably going to ruin it. And now you didn't experience it firsthand.
Because you're looking down at
because you were messing with equipment. So we recommend if it's your first time, don't try and do photography. There's a lot of education you'd want to do before you try and use a camera.
And you can get a lot of really sweet pictures off the internet, too.
Yeah, exactly.
And some of them are free commons, too.
Yes, exactly, as many of the ones that we just displayed are.
So again, we want to reiterate, please be very careful when you do this. Again, proper protection, eye protection, or use the projection method, or watch it on the internet. It'll be perfectly safe that way. Now, I do want to thank Tim for coming in and presenting on this upcoming topic. And if you have any other questions or would like some more information, you can go to our club website. The address is down there at the bottom of your screen. So again, Tim, thank you again for being on the program.
And thank you for having me.
You're welcome. And coming up next, as always, is Stephen with What's Up in the Night Sky. Stephen wasn't able to be here this month, so I'll sit in to do What's Up. This is for May 2017, and we'll start with the phases of the moon. The first quarter moon appears on the 2nd of the month, the full on the 10th. On the 18th, we have third or last quarter. You can use either term. And the new moon appears on the 25th. Now, the moon's orbit around the Earth is not a perfect circle, so at one point it's closest to the Earth, another point it's farthest away. Its furthest point, called apogee, is on the 12th, right after full moon, when it'll be 406,000 kilometers distance from our planet. Perigee, its closest approach, happens on the 25th, which also coincides with the new moon. Now, if it had been a full moon, the moon itself would have looked a whole lot bigger, but since we can't see it in the first place, oh well. However, this will give us some of the highest high tides for the month, with both the sun and the moon lined up across from the Earth. The perigee distance, by the way, is 375,000 kilometers. Now, of the 8 planets in our solar system, 5 of them we can see by just looking up and using our eyes. No other assistance is required. Mercury we will find in the morning about mid-month. Look towards the east, low to the horizon. Mercury never gets very high up. It'll be best late in May. Now, Venus is also in the morning sky. It's best seen about 2 hours before the sun comes up, and it will be brightest for May in the first part of the month. It'll be very, very bright, so trust me, you won't miss it. Next, of course, is Mars. It's very low on the western horizon at sunset, be very difficult to see. Also, what will make it difficult is the fact that it will be very close to the red star Aldebaran, part of the constellation of Taurus the Bull. So you might mistake the two, but it'll be pretty difficult to see unless you have a really clear, unobstructed view of the western horizon. Jupiter, on the other hand, dazzles. It's in the southeastern sky at evening. It's in the constellation of Virgo the Maiden, and is just about 5 to 7 degrees above the brightest star in Virgo. Its name is Spica. Now, while Spica is a fairly bright star in and of itself, Jupiter shines much, much brighter. Saturn, the planet with all the beautiful rings, is in the south about an hour before dawn. It'll be actually best viewed in June, when it will be near its maximum tilt of the rings towards us. So we'll be able to see as much of them as we can from here on Earth. So that'll be quite a sight, especially in a telescope. The other 2 planets in our solar system, Uranus and Neptune, well, Uranus is in Pisces and Neptune can be found in Aquarius. But for them, you will need a small telescope, 3 or 4 inches in diameter. Now, if you're traveling south of the equator, you can check out the Eta Aquariid meteor shower. Its peak is on May 6th with about 50 per hour. Up here in the northern hemisphere, in the Midwest, very few will be seen. Now, if you have a pair of binoculars, there are several deep sky objects that you'll be able to take a look at just using those binoculars. 2 of the nicest, 3 actually. One is called M13. The M stands for Messier, one of his objects. That is in the constellation of Hercules. Looks like a nice little cotton ball seen in a pair of binoculars. Also similar appearance is M5 in the constellation of Serpens, which comes off near Ophiuchus. And another one, M4, which is in Scorpius the Scorpion, very close to the bright star Antares. Another one, might be a little bit more difficult to see because it's lower in the west, is M44 in the constellation of Cancer, the Crab. It's also known as the Beehive Cluster. Now, there's one little object called Merlot 111. It's the puffy little tail at the end of the lion's tail. And that's our look at what's up for May 2017. Keep looking up. It's the best free show in the universe.